for a problem like this one, multiply, and we are multiplying a binomial. So we got 3a minus 4 to the power of 2. To the power of 2 means it's repeated multiplication. So we're going to take this and show it multiplied by itself this way, and then we can use distribution in order to, well, I guess it wouldn't simplify it necessarily, but it's going to make it a lot easier to work with. So for example, we've got to take the 3a and multiply it by another 3a. So 3a's times another 3a's. 3 times 3 is 9. A times a would be a squared. And that's our first set of multiplication. The second set would be 3a's multiplied by negative 4. And again, 3 times negative 4 would be negative 12. And that's how many a's you have. Then we're going to distribute here the negative 4 to the 3a's, so that's negative 4 times 3a's, or negative 4 groups of 3a's, which again would be another negative 12a's. Now there is a rule to simplify this, or multiply these, but I'm ignoring that rule just so that we can get used to the distribution, which is really just multiplication. And then finally, I have a negative 4 times another negative 4, which will end up being a positive 16. So right down here, this is what we end up with. But we now notice that there are two like terms in the middle that we can combine. If you're looking at the a squared as though it can be combined with the other a's, a to the power of 2 has a different exponent, which means it's a different type of term. It's a different or unlike term. However, I am able to take the negative 12a's there and the other negative 12a's and determine how many a's this would be. So that's negative 12. Minus 12, or negative 12 plus negative 12, which would be negative 24 of those a's. Now I can take the other two terms, the 9a squared, and also the positive 16, and combine it there, which gives me my final answer of 9a squared minus 24a plus 16. And that does it for this one. There's no need to solve here because it doesn't actually equal anything. All we needed to do was take the 3a minus 4, multiply it by itself, and then combine any like terms, which we do have. All right, that'll do it for this one.